we're going to do combustion analysis to determine the percent composition of ascorbic acid. And that means we're going to burn ascorbic acid, which only has these elements, carbon, hydrogen, and oxygen. Burn it completely, and the two products are CO2 and water. And the trick is that we know that all of the carbon in the ascorbic acid ends up here. All of those carbon atoms end up in the CO2. So what we can do is take this 1.50 grams of CO2 and figure out what mass of carbon must have been in that, or must be in that. Now, we need to have numbers here. Where are we going to get those numbers? We need the ratio. And what we can use is the molar mass. So let me show you. The molar mass of CO2 is a 12 from the carbon plus 2 times 16 from the oxygen. And so the total is 44. Okay. And so that tells me that for every 44 grams of CO2, the whole thing, 12 of that came from carbon. And so now I know that the original ascorbic acid must have had this number of grams of carbon atoms, basically. Okay, we can do the same thing for the hydrogen. This time we're using the water. And we want to know what mass of hydrogen came from the ascorbic acid. So what I do is I put grams of water here. And again, I'm using the molar mass. The molar mass of H2O is 2 times 1 for the hydrogen plus 16 for the oxygen. So the total is 18. And of that, we know that 2 came from the hydrogen. And I'm going to use, hydrogen on the periodic table is 1.01. And when I do, that last one gets rounded off here because I only use 3 sig figs on the oxygen. But I'm going to go ahead and use the 1.01 just to have another digit there so I don't lose so many sig figs on this part. Okay, well, I know how many grams of carbon and hydrogen that I had, and remember, this might be the mass of what's in the products, but it is also the mass of carbon and hydrogen that was in our original ascorbic acid. And so how I figure out my oxygen is that I know that there was a total of 1 gram in the ascorbic acid. And so that's the carbon, hydrogen, and oxygen. And so basically what I'm going to do is subtract, and I'm going to write it out, even though you might just be plugging this in your calculator because I want to look at the sig figs. So it's kind of written out funny. And I really plugged this in my calculator, but I wanted to line it up and cut it off to show where the sig figs would go on your answer. And let me label this just so we're clear on what happened. This is the grams of carbon, and this is the grams of hydrogen. So we're left with the grams of oxygen. Okay. And now we can get a percent composition. So if you think about it, what we're going to do, I'm going to zoom out. These numbers that we have, those are the amounts out of we burned 1 gram of ascorbic acid. So if I wanted the percent carbon, I would take the mass of the carbon divided by the total compound and times 100. And so that's pretty easy. I end up with 40.9% carbon. So it made it pretty easy with the math that we used a 1 for the amount that we burned. It's pretty easy to get the other two as well, just looking at them, and basically we're multiplying by 100. And this should add up to about 100. It doesn't quite, but that's just because of rounding.